Hi, this is Pat Dion. This is Solution Wiki, and our section is colligative properties. Molarity and mole fraction. Colligative properties are dependent on the amount of solute dissolved in the solvent. Two ways to show the ratio of solvent to solute particles are molality, and mole fraction. Molality is the number of moles of solute dissolved in 1 kilogram of solvent. The formula to find molality is moles of solute divided by kilograms of solvent. The sample problem we will be going over is how many grams of potassium iodide must be dissolved in 500 grams of water to produce 0.060 mole Ki solution. We started off this example by listing what we already know: the mass of water, concentration, and molar mass of potassium iodide. First, you multiply the ratios of potassium iodide and water, H2O, and then you multiply that by the kilograms of H2O, the solvent. So here the solvent is 0.5 kilograms. Multiplied by the two ratios, we end up with 5.0 grams of potassium iodide. Another way to determine the ratio of particles between the solvent and solute is mole fraction. Mole fraction is the ratio of moles of solute to the total amount of moles of the solvent and solute put together. This is the formula for mole fraction. N to A will be the moles of A solvent, and NB will be the moles of B solute. So in this mole fraction, first we must put the moles of A solvent over moles of A solvent added to moles of B solute. This will result in giving us a ratio of the particles of a solvent to a solute.
Hi, I'm Lizzie Wilk, and I'll be talking about freezing point depression and boiling point elevation. The magnitudes of the freezing point depression, delta TF, and the boiling point elevation, delta TB, of a solution are directly proportional to the molar concentration M, assuming the solute is molecular, not ionic. Proportionality between the freezing point depression and the molality can be expressed as an equation: delta TF equals KF times M. Kf is the mole freezing point depression constant, which is equal to the change in freezing point for a 1 molar solution of a non-volatile molecular solute. This depends upon the solvent. The boiling point elevation of a solution can be expressed in an equation such as delta Tb equals Kb times M. Kb is the molar boiling point elevation constant, which is equal to the change in boiling point for a 1 molar solution of a non-volatile molecular solute. Here's an example problem of calculating the freezing point depression of a solution. Antifreeze protects a car from freezing. It also protects it from overheating. Calculate the freezing point depression of a solution containing exactly 100 grams of ethylene glycol, which is antifreeze, and 0.500 kilograms of water. The list of knowns and unknowns is shown on the slide. To solve the problem, you must first use the molar mass of C2H6O2 to convert the mass of solute to moles. Then, calculate the molality of the solution, and finally calculate the freezing point depression. The freezing point depression is 5.99 degrees Celsius.
Hi, this is a quick recap of what we learned today. First, we have learned that molality and mole fraction are two ways of expressing the ratio of particles between a solute and a solvent. Next, we have learned that both the boiling point elevation and freezing point depression are related to they are related to colligative properties because both these solutions are directly proportional to the mole concentration. Thank you for watching our video. I hope this informed you.